So my name is Thorsten Höffler from ETH Zurich, and I'm here together with Andrew Lumsdaine from Indiana University at the ACM PASC16 conference in Lausanne. So Andrew, we're at day 3 of the conference, and you've been here since the very beginning. And you gave a very interesting talk yesterday on a potentially groundbreaking new view on a large-scale graph algorithm. So could you tell us a little bit about this?
Well, yeah, so we've been working for some time, actually from the time you were at Indiana University, on how to make graph algorithms work better on large-scale systems. And of course, as we found, the runtime system that maps the algorithm to the underlying hardware has a very significant role in the performance of the parallel graph algorithms. So we were, in this talk, and the accompanying paper, we were analyzing this very carefully, finding out which effects in the runtime actually cause differences in performance in the actual algorithms.
So how did you decide to submit this to the ACM PASC16 conference?
Well, for a couple of reasons. One, this is a newer conference, and so it has the flexibility, while still being well respected and so forth, of having papers that are a little more on the cutting edge. It can be difficult sometimes in more established venues to really present something that's pushing the envelope. And I think the review process helped this quite a bit, because we, in the review process here, we submit the paper once, it comes back for comments, and we can actually make changes and resubmit. It's very much more like a journal review process, and you really cooperate more with the referees rather than having an adversarial relationship with them. So it helped us improve the paper quite a bit, actually, in the interim, and improve the work, in fact.
Okay, so you've been at the whole conference, so what have you learned in terms of new things or exciting things that you would want to share with our viewers?
Well, one of the very exciting things was actually the session I was just in about the modeling the human brain. Is something that is very, very large scale to do the simulations. They were talking about having to use an exabyte of memory, and so correspondingly, there'd be some something for the computation, and and of course it's very different. The type of computation there are quite different from the traditional discretized PDEs in scientific computing. So I think it'll be that simulation in particular, but others similar to that, will be one of the future directions, big directions in HPC, and will hopefully change the field significantly as well.
Yes, exactly. You're nicely summarizing what the key focus of the PASC conference is, to move towards the next generation of scientific computing and see all these challenges happening and changing. So we're looking forward to your submission next year to the ACM PASC papers track, and thank you very much.
Okay. Well, thank you.
Thank you.